All right, scientists, welcome to your last lesson of your Environments and Survival unit. Make sure you have something with you to write with and something to write on, and we will get started. Now our goal today is really to analyze some design arguments and then reflect back on what you've already learned throughout the unit. As biomimicry engineers, we designed robot necks and mouths to help solve the problem of invasive plants. The engineering firm has sent us a new message, so let's read it. It says here, "Hello biomimicry engineers. I'm very excited to hear about the robot necks and mouths you have designed. Before I review your designs, please prepare design arguments and present them at the Biomimicry Engineering Conference. Be sure to discuss the evidence you have to support your ideas about how well your designs meet the criteria." The kind of argument that engineers make is a design argument. A design argument is different from other kinds. For design, you really want to make sure that what you're showing is what you know to be the best because it meets certain criteria. Here's an explanation of it as well. In a design argument, engineers try to convince people that their designs meet the criteria well. To do this, they use evidence to support their ideas. For example, in a design argument, engineers explain how well the criteria are met and provide evidence to support ideas. Evidence can be information from tests that they've run or ideas from something that they read or investigated in class. That would be what you use. Remember reading about cockroach robots. We will look closely at a design argument that they could write to convince people that their design met one of their criteria. This section here includes how the engineers made their design, and that's at the top where it says how my design meets the criterion. We added spines to our robot legs so it could move in small spaces even when its feet are pushed out. And the bottom section includes what the engineers observed when they tested their robot. Evidence. Our design worked well to move into small spaces. We observed our robot move into a small crack. This page is an example of how to prepare for a design argument. And it says here the directions. You want to look at what data we've collected, which might be going back to look at a video from before this. You want to look at the criteria and then think about how your design met each piece of the criteria. So how did it actually answer each parts of those, the robot neck and with the robot teeth. Then you'll use evidence from your tests and things like that we did together to support your idea. Engineers doing this will describe what they did when they made a test version of the neck or when they chose the teeth of the RoboGrazer simulation that helped meet the criterion. They also explain how their design met the constraints they had. For example, and a lot of you might feel this, the materials available. Using only some materials is called a constraint. That means you can't just use anything that you want, you can only use a little bit, and that's a constraint, and that's okay to have. Our data of neck length and our neck test score shows how well our design met the criterion of reaching plants that are high up in trees or on the ground. When we ran our simulation, our score is the data that shows how well our design met the criterion of breaking plants down into very small pieces. So we've actually been able to meet the needs of all the criteria listed. Now, Biomimicry Engineering Conference. Wouldn't that be a cool thing to go to? We can see what a Biomimicry Engineering Conference might be like. And it's going to be a little bit different than what we might be used to if we were in class. One part of being at a conference is being a listener. A listener is someone who asks good questions based on what they hear. So you don't just go to a conference just to talk. You also want to be a listener. And this is a really important skill if you're going to present at something like a conference with engineers. Here are some examples of questions you could ask someone if they were talking to you. Which criterion did you choose for your argument? How does your design meet the criterion you chose to talk about? What's your evidence? What's your favorite part of your design? What part was the hardest to design and why? And what would you change about your design if you had more time? Now, you don't just have more time, but you also aren't in school where you're able to just make a design with your teacher. So if you are also constrained by something like materials or not having a science partner to work with, that would be something that a listener would ask you about and that you would be able to answer. After listening, you can also be a presenter. The resources to help you as a presenter are things like your notes, any recordings that you have, so any data, and then any evidence based on your own tests. So the engineering conference for round 1 and 2 would look like this if we were able to fully do it. Round 1, listeners rotate at one desk to listen to the presenter from another pair and ask questions. Presenters stay at their desks. Then in round 2, you switch and the listeners rotate one more desk and listen to a new presenter. Now we'll spend the last part of our lesson reflecting on the unit. Remember our investigation question. How do engineers learn, plan, make, and test their designs? Now we'll see if we can answer the question we have been investigating. How do engineers learn, plan, make, and test their designs? Well, you've been working as a biomimicry engineer to design the neck and mouth for a robo-grazer, and that might have given you ideas about how to answer this question. It also might help with our chapter question. How can engineers use what they learned from organisms' traits to design solutions? Well, here's your example of your robo-grazer, and that's what it looked like in real life before they added all the rest of the pieces. But how did learning about the giraffe traits help design this version of a robo-grazer for the neck and what we did for the teeth before our simulation? So be thinking now, how could you answer this question? How can engineers use what they learned from organisms' traits to design solutions? Remember the parts of the giraffe that we used and how those traits help us design something like the robo-grazer. You might also have an answer now for this question, and this is our whole unit question. Why are different organisms more likely or less likely to survive in an environment? And I think the biggest takeaway from this is really thinking about traits. Remember, adaptive traits are traits that change or traits that adapt to an environment. So really what happens is the environment's the thing that changes. The adaptive trait just makes the organism more likely to survive. And that's really important to think about. So remember studying the mice, for example. If they were on a sandy area and it was light brown, the light brown fur is an adaptive trait. Now there were dark brown fur mice, but they don't survive as well. So they were eaten quicker by predators. They couldn't reproduce. So only the light brown fur mice could reproduce. That made there be more light brown fur mice. The dark-haired mice could not just choose, okay, I'm going to change my fur color today so that I survive. That's not how that works. So just remember, the thing that actually changes is the environment. And some traits are adaptive at one time and they can be non-adaptive at another. Remember thinking about the organisms where it was really dry and they ate a lot of insects, and then the environment changed, it became wet, there were more fish, and the birds had to change. They changed their entire mouth and their feet so that they could catch fish and survive better in that environment. So they didn't just change, but the ones that had webbed feet were able to survive better, and the ones that had mouths that could actually eat fish were able to survive better. The long pointy mouths those were for insects. Those organisms didn't survive as well. Now, if they have a hard, thick beak, remember, they can't just decide, okay, I'm going to change my beak today so I can eat fish. That's not how that works. They just didn't survive because they couldn't find the right food. The other organism with the better mouth for eating fish and the better feet for swimming, they survived, they were able to reproduce, and there were more of those. We spent the most time thinking about snails and the yellow-shelled snails versus the banded-shelled snails. We talked about shell strength, we talked about the color and how it could blend in or not. Now, the yellow-shelled snails were eaten more. It doesn't mean they could choose to change and become banded-shelled snails. They were just eaten more and they were dying off. The banded-shelled snails stayed alive longer and could reproduce more, so there's more of them now than there was 10 years ago. Okay, so hopefully you have a solid answer for this question. Why are different organisms more likely or less likely to survive in an environment? Here is one last reflection question for you. And it says here, from the beginning of the unit until now, how have your ideas changed about why different organisms are more likely or less likely to survive in an environment? Congratulations on everything that you have done and learned. You talked, read, wrote, and investigated like scientists and engineers throughout the unit in order to figure out an answer to this question. As biomimicry engineers, we learned a lot about how many different organisms, including their traits and their environment, in order to figure out why different organisms are more likely or less likely to survive in an environment. We observed different traits and the structure of some of those traits, and we thought about how the structure is good for a particular function. Then we used all of what we learned to explain why the growth snails with yellow shells were surviving well at some times, but not well at other times. So, an amazing job again in this unit. Think back on the question you see here on this slide. Think back over from the beginning of the unit all the way through. Excellent work. You should be proud of everything you've done. Until I see you again, keep thinking like scientists and like biomimicry engineers.